All right, let's dive into the code for finding the most popular superhero in the Marvel Universe and get our answer. Who will it be? We'll find out soon. Well, let's find out who the most popular superhero is and turn this into some code. So, go to the resources for this lecture and you're going to download three things. The Marvel graph.txt data file, which contains our social network of superheroes, and our Marvel names.txt file, which maps superhero IDs to human readable names. And finally, get the most popular superhero script. Download all of that into your Spark course folder. Hit pause, go take care of that right now, if you haven't already. And then we'll open up most popular superhero.py in your Python environment. All right, let's see what's going on here. So the usual stuff, and let's skip down to the meat of it. So the first thing we're going to do is load up our names file into an RDD called names using sc.txt file. Now we're going to do this name lookup a little bit differently than we did in the previous example. So instead of using a broadcast variable, I'm going to store the superhero ID to name information as a key value RDD instead. And that too can be used across different nodes on your cluster if necessary. So just another way to solve the same problem. So what we do is we load up that text file and then we use the parse names function to map it from lines of input data to actual key value pairs. And if we look at what parse names does, it splits it based on the \delimiter, extracts the superhero ID, stores it as an integer as a key, and then after encoding things into UTF-8 format as a string, stores the superhero name as the value. So at this point, names RDD is a key value RDD, where the key is the superhero ID, the value is the human readable and displayable name of that superhero. So we'll use that later. Next, we load up the graph itself, the social graph of superheroes, into a lines RDD because it's just containing raw lines of input. And our mapper will turn that into something more useful with the count co-occurrences function. And that's going to split up each line based on white space and return key value pairs, this time of the superhero ID, which is the first ID in the list of each line, followed by just the number of elements found in that line, subtracting 1 to account for that first entry. That's the hero ID that we're talking about. So the output of this will be a key value RDD, where the key is the superhero ID and the value is the number of times that hero occurred with other heroes within this line of data. Now remember, heroes can span multiple lines, so we need to call reduce by key next to actually add them all up together. So in the case where we have more than one line for a given hero, our standard lambda function here for combining things together in a reduce operation will just add them all up. So if we have two different entries for, superhero ID 5, it will get the counts for each and add them together and reduce them into a single entry here. So now we have total friends by character, which is itself a key value RDD, where the key is the superhero ID and the values are the total number of co-occurrences seen for that character. So we're getting close to our answer here. Now we have the information we need in that RDD, but we need to find the maximum number of friends for all of the people in it. So kind of like when we want to sort things, we need to flip things around to get what we want. Since we want to get the maximum count of characters, we need to make that count the key. So we're just going to do our usual flippy trick here and have a mapper that just swaps the keys with the values. You've seen that a few times before. And what we have now is a key value RDD where the key is the count and the value is the superhero ID. And now we can just call max on that key value ID, which will find the maximum key value, which is basically going to give us back the entry for the superhero ID with the most co-occurrences. Finally, we need to look up a name so we can actually display who that is. And we're going to use that names RDD that we created earlier to look up the name for that character ID, and that will give us back the value from that key value pair. That value is simply a list that contains a single string, so we're going to extract that value by using the array operator 0 there. That will give us back the actual name string itself into most popular name, which we can then just print out. And we also have the count that's still in the key value from our original result that we can use to display as well. So we can say who is the most popular superhero and how many co-appearances did that person have with other superheroes in our data set. So I'm itching to find out. Who do you think it's going to be? Any guesses? My guess would be Spider-Man, but let's see if I'm right. Spark-submit. Most popular superhero.py. Off it goes. And the answer is... Ooh, isn't that a surprise? 1,933 co-appearances for Captain America. Yay, he is the most popular superhero in our dataset. Seems like a pretty positive role model, and his character seems like a nice guy. Personally, I prefer a more global perspective on the world, but there you have it. A little bit unexpected. I would have guessed someone else, but Captain America it is. Captain America? I wouldn't have guessed that. But hey, I guess the folks at Marvel like the guy. He shows up in a lot of comic books, it turns out. And there you have it, an example of using Spark in a little bit more of a complex manner. Let's keep on playing with that Marvel superhero data and do some more interesting stuff with it next.